Let us start with a very important topic called Z transform. See, transforms, whether it is Fourier transform, Z transform, fast Fourier transform, they are very, very important, especially if you belongs to uh, electronics branch or electrical branch, though it is used in other branches as well, but it has a lot of importance when it comes to electronics and electrical, right? So now let us understand this, like Laplace transform you have already done. Now this is another Z transform. So let us try to understand what exactly is a Z transform. See, what are the major application of Z transform? A Z transform play important role in analysis and representation of discrete time linear shift in variant system. So basically it involves the discrete field. So there is a difference between discrete and continuous. But the same thing you studied in probability also. Continuous means like the interval from 0 to 1, 1 to 2, infinite numbers in between. Discrete means counting 1, 2, 3, 4, like our simple natural numbers. Okay, same way counting, right? So that is called the discrete. And if I say the weight of one person is 5, the weight of other person is 10, the weight of third person is 15, this is a discrete distribution I am doing. If I say the weight of all the students lies between 30 and 50 kg, continuous. So this is a term discrete and continuous means. So Z transform is more involved in the discrete time linear shift. Okay. It is an application in control system of engineering and it is also used in advanced statistical problems. Basically, the very important use which you will be doing is the solution of difference equation. See students, you learn Laplace transform. Okay. Now when you learn Laplace transform, you said it is applied to solve the differential equations. I am saying now we are learning Z transform which is used to solve difference equation. What is difference equation? In numerical methods you have done difference operator. This is called the forward difference operator. When I apply it here, it gives f of x plus h minus fx, right? And we used to write it like this also. Yn is equal to yn plus 1 minus yn. So we can also define second order difference, this thing, right? So this type of difference, this difference gives me the difference equation. So Z transform help me to solve these difference equation that you will learn at the end of the module. But first we need to understand the basic concept. Now before starting the basic concept, there are few results which we have to use. So all of you note down these results. They are very basic results which you have used earlier. And now it is required to solve the question. The first result is 1 minus x to the power minus 1 is 1 plus x square plus x cube, and it's an infinite series. Then 1 minus x minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube. Then e to the power I theta is cos theta plus I sin theta. E to the power minus I theta is cos theta minus I sin theta. Cos hyperbolic n theta is e to the power n theta, e to the power minus n theta upon 2. Sin hyperbolic, this only become minus. So these 6 formulas I will be using very often while doing the questions. Okay. So now let us start with the basic definition of Z transform. See, the way I defined Laplace transform. If you remember, Laplace transform of any function of t was integral 0 to infinity e to the power minus st ft dt. Okay, and we used to write this result is as fs. See, Laplace transform is not connected with Z transform. Why I am comparing telling? It will become easy for you to understand it, because when there is a comparison, things become more clear. Okay, same way, now instead of L, my symbol is this, Z transform. Now instead of ft, I will have un. Okay, what is un? I'll tell you. Okay, and what is the definition? The definition is Z transform of un is equal to summation n is equal to 0 to infinity un z to the power minus n, which we represent as u of z. So now do the comparing. Here what I used to do, there was a function of t. When I operated L on it, this see, integral means continuous. This operator was working and I was getting the answer in terms of s. In Z transform, you will have functions in n and you will apply this summation, okay, and the answer will be in terms of Z. Correct? So you can understand like this. This box is Z transform. I am throwing the functions of n and I am getting the functions of Z. That is what is happening. So this is the basic definition of Z transform. Correct? Now how I will define the Z transform? Let us see. If un is equal to fn, okay, for all n is equal to 0, 1, 2, like this, and un is equal to 0 when n is less than 0. If n is less than 0, un becomes 0, right? So un is some function of n, then Z transform of un is given by Z transform of un is equal to summation n is equal to 0 to infinity un z to the power minus n, and my answer will always be in terms of z. Okay, this bar is just to differentiate u from this u. They are different functions. Correct? And the same way as we do in Laplace transform, Laplace inverse also exists. Same way, if I take Z transform inverse of uz, my answer will be un. So that also we will learn. Okay. So this is a basic concept. Just remember this formula and you can apply it on any function. So now let us start with the questions so that the definition is more clear to us. Let us start with the simplest function 1. Now if I want to find out Z transform of 1, okay, so Z transform of 1 is equal to, what is the formula? Summation n is equal to 0 to infinity. Sorry, it is 1 to infinity, not 0 to infinity. It is 1 to infinity. Okay. Sorry, it's 0 to infinity. By mistake, I wrote 1. Okay. Now, what we are going to do? So, this is the definition. We are very clear about it. Okay. So, now since here n is starting from 0, so summation also start with 0 only. Now, when I am putting this, what is the definition? First is un. What is un here? 1. So, put 1. And then z to the power minus n is a fixed thing. Now, how to open a summation? First put n is equal to 0, or better you write like this, n is equal to 0 to infinity 1 upon z to the power n. Now let us open the summation. How we open the summation? We put different values of n. First you put n is equal to 0 here. Now 1 upon z to the power 0 is what? Anything to the power 0 is 1. So first term is 1. Now plus. Now put n is equal to 1. So 1 by z. Now put n is equal to 2. So z square plus 1 cube, like this. Now this is the series I got. Now look at this result. First result which I gave you. 1 minus x to the power minus 1 is this series. I got exactly this side. Right. So now this will be equal to 1 minus 1 by z to the power minus 1. Like there in the standard formula I have x. Here I have 1 by z. Now this becomes, take the LCM, z minus 1 upon z to the power minus 1, which is equal to z upon z minus 1. So this is my first formula. Z transform of 1 is z upon z minus 1. Okay. Now let's move to the second one. Now I want to find out z transform of k to the power n. So again let us apply the formula first. Z transform of k to the power n is equal to summation n is equal to 0 to infinity. Okay, un. What is un here? K to the power n and z to the power minus n. Can I rewrite it as summation k to the power n upon z to the power n, and n is from 0 to infinity. Now let us open the summation. First put n is equal to 0. So anything to the power 0 is 1. So first term will become 1. Plus n is equal to 1 means k by z. N is equal to 2 means k square by z square plus k cube by z cube and dash dash dash. Correct? Now again, if you observe, this is the same series I am getting. Okay, the only difference is the value of x here is k by z. Okay, what is the series? 1 minus x to the power minus 1 is equal to 1 plus x square plus x cube dash dash dash. So this series I am getting this side here. And what is the value of x? X is nothing but k by z. So what should be the answer? Answer should be this. So I'll put 1 minus k by z to the power minus 1. Take LCM, z minus k upon z to the power minus 1. So z upon z minus k is my answer. So this is very important result and very often I will be using it. Okay, z transform of k to the power n. Now come to the next question. Now look at this question. Both the questions are depending upon the same concept. Now can I write, I'll just make a partition and I'll do both the questions for you. Here z transform of e to the power minus a n I am writing. Can I write e to the power minus a and n outside? So now tell me, what is this thing? This is some constant. So isn't it? It is same as k to the power n, z transform of k to the power n, where value of k is e to the power a. So what is the z transform of k to the power n? Just now we have derived z upon z minus k. So I will be using this result here. Okay. So now here k value is e to the power minus a. So answer will be z upon z minus e to the power minus a. And I am done. Same way this side, I can write z transform of e to the power a outside n. So now k value is this. So what will be the answer? Z upon z minus k, and k is e to the power a. I am done. Simple. So these examples are very simple. Only you have to remember few basic formula. And the basic most standard formulas are z transform of 1 is what? Z upon z minus 1. Okay. Then z transform of k to the power n. It's very important. It is z upon z minus k. Okay. So now let's move further. Okay. Now next is z transform of this term. Now again, what is this? Cos theta plus I sin theta. If you remember, first page I gave you the formula e to the power I theta is equal to cos theta plus I sin theta. So same thing I'll use here. So this becomes z transform of e to the power I theta power n. Now again, what is this function? What is this thing? This is to k. So I can use the formula z transform of k to the power n. And what is z transform of k to the power n? Z upon z minus k. Right? So now I will be using the formula z upon z minus k here, where my where my k in this particular question is e to the power I theta. Right? So let me substitute z transform of e to the power I theta power n is equal to z upon z minus e to the power I theta, which is my answer. Okay, now let's move to the next question. Now z transform of hyperbolic n theta. So here again I will use the standard result. What is cos hyperbolic n theta? Cos hyperbolic n theta is e to the power n theta plus e to the power minus n theta upon 2. This is the formula for cos hyperbolic. So now let's find out z transform for this. So now z transform, in place of cos hyperbolic n theta, I'll write e to the power n theta plus e to the power minus n theta upon 2. Right? Now I'll take 1 by 2 out and I am left with z transform of e to the power n theta plus z transform of e to the power minus n theta. And in my previous question, I have solved these two separately. Again, I'll show you. Now tell me, can I write it like this? Z transform of e to the power n, e to the power theta outside n, plus z transform of e to the power minus theta outside n. Correct? And now which formula I can apply? I can apply the formula z transform of k to the power n is equal to z upon z minus k. Right? Now in this term, what is the value of k? E to the power theta. And in this term, what is the value of k? E to the power minus theta. So let's put the value. So 1 by 2. So this will become z upon z minus e to the power theta plus z upon z minus e to the power minus theta. Okay, now take LCM. So 1 by 2, z I can take out. So I am left with z minus e to the power minus theta plus z minus e to the power theta upon. Multiply denominator, I am taking LCM. So this becomes z square. Okay, then minus z e to the power theta plus e to the power minus theta plus 1. See how I am opening? This z went out. Okay. Now when you take LCM, this will become this side numerator and this will become this side numerator. So z minus e to the power I theta plus z minus e to the power I theta. Correct? Here this is different. See, the power of exponential is different. That's why I am not able to combine it. Now denominator, just multiply these two terms. So z into z is z square. Then z into e to the power minus theta. Then minus z into e to the power theta. Plus e to the power theta into e to the power minus theta will be my 1. So that is why 1 came. Okay. Now next step, z by 2. 2z minus e to the power theta plus e to the power minus theta upon z square minus z e to the power theta plus e to the power minus theta plus 1. Now again apply the reverse of cos hyperbolic. Okay, what is cos hyperbolic theta? It is e to the power theta plus e to the power minus theta upon 2. So what is e to the power theta plus e to the power minus theta? 2 cos hyperbolic theta. That I will substitute here. So z by 2, okay, in bracket 2z minus 2 cos hyperbolic theta upon z square minus 2z cos hyperbolic theta plus 1. If you observe, I can cancel this z2 here and my final answer will be z square minus z cos hyperbolic theta upon z square minus 2z cos hyperbolic theta plus 1. Now on the same line you can do for z hyperbolic sine hyperbolic n theta, and here it will be e to the power n theta minus e to the power minus n theta upon 2, and you will take z transform of this. Exactly same way 1 by 2 you take common. Okay, and then this you can write e to the power theta outside n. This you can write e to the power minus theta outside n. Apply the formula of k to the power n. Take the LCM and you will get this result. Okay. Now let's move to the very important question where you have to find out z transform of sine theta and cos theta. This will help in so many questions where sine and cos is involved. And this is a standard result which you can use for further other questions. But many times they ask, find out z transform of cos and theta, find out z transform of sine and theta, so that you should know how to derive it. So now let us start it. Now we know that e to the power ni theta is equal to cos n theta plus I sin n theta. So this is my first result. Correct? So understand one thing. When I say I want real part of e to the power ni theta, means I want cos n theta. When I say imaginary part of e to the power ni theta, means I want sin n theta. In last step, I will be needing this information. So now let us start with z transform of e to the power ni theta. Okay. So now how I can write this? This can be written as z transform of e to the power I theta and outside n. Now again, as I used earlier, z transform of k to the power n. I told you this is a very powerful formula. Z upon z minus k. And in this case, k value is e to the power I theta. Now let us apply it. So this becomes z upon z minus e to the power I theta. Okay. Now I got z upon z minus e to the power I theta, but in denominator, I can't handle this I. So I will rationalize it. Usually when you rationalize, you multiply and divide it by the opposite sign. But in case of exponential, it is done like this, minus e to the power minus I theta. Sign is changed in power of exponential and divide by the same term. Okay, now open the bracket, z square minus z e to the power minus I theta upon denominator z square minus z e to the power minus I theta minus z e to the power I theta plus e to the power I theta and e to the power minus I theta. Okay. So this is z square minus z e to the power minus I theta. Okay. Now e to the power minus I theta is what? E to the power minus I theta is cos theta minus I sin theta. You can see the results given in the first page upon z square minus z in bracket I am getting e to the power I theta plus e to the power minus I theta plus 1. Okay. Now e to the power I theta plus e to the power minus I theta is what? It is equal to 2 cos theta. Right? So see the result. Those who are confused how I wrote this, I'll explain you here. See, I told you that e to the power I theta is equal to cos theta plus I sin theta. Okay, and e to the power minus I theta is equal to cos theta minus I sin theta. Now tell me one thing, can I add these two equations? If I add these two equations, what I'll get? This side it will become, okay, let me do here. So it will become e to the power I theta plus e to the power minus I theta is equal to 2 cos theta. Correct? The same thing I am using here. I got this result. In place of this, I am writing 2 cos theta. Same way, suppose if it was minus, I would have subtracted this to get the value of sin theta. Okay, so this result only I am using here. Correct? Same way in the numerator, which result I used? I was having e to the power minus I theta. So e to the power minus I theta value, this I have written here. Okay, so now let's continue with the question. These are the results which you have done in grade 12th also. But anyways, if you don't remember, please note down from the first sheet. Okay, now let us simplify this result. Z square minus Z cos theta plus IZ sin theta. Okay, upon Z square minus Z 2 cos theta plus 1. Now I'll rewrite this as z square minus z cos theta upon z square minus 2z cos theta plus 1 plus I z sin theta upon z square minus 2z cos theta plus 1. Now students, tell me one thing. I started with z transform of this thing. Okay, and I told you this means cos n theta plus I sin theta. So what is the real part of this? The real part of this is this first part and imaginary part is this. So this is nothing but z transform of cos n theta, and this is nothing but z transform of sin n theta. Okay, because we started like this, e to the z transform of cos theta and sin theta was required. I started with this. I know that real part of this exponential is cos n theta and imaginary part of this is sin n theta. So I started with the z transform, and in the z transform I separated real and imaginary parts. So the real part is answer for cos n theta and imaginary part is the answer for sin n theta. Now let us apply this formulas on some questions. Okay, so let us go to the question. Now this is a very important question again. Now it has z transform of 2n plus sine n pi by 4 plus 1. Okay, we have not done this z transform of n. I think I skipped. It was there only. By mistake I have missed. Okay, no issues. We will do z transform of n also. First, let me just use the result, then I'll tell you how to do. See, just remember for moment that z transform of n is equal to z upon z minus 1 square. Okay, so using this result, we will solve. Okay, now can I rewrite this as 2z transform of n plus z transform of sine n pi by 4 plus z transform of 1. Okay, now 2 z transform of n is what? It is z upon z minus 1 square. Correct? Now plus z transform of sine n pi by 4. So here you need to use your formula. What is z transform of n theta? Z transform of n theta is this. Not I. Remember I, no, only imaginary part. So it is z sine theta upon z square minus 2z cos theta plus 1. So let us apply here. So z sine of pi by 4 upon z square minus 2z cos pi by 4 plus 1. Because theta value here is pi by 4. Plus, what is z transform of 1? 1 upon z minus 1. That we have already, z upon z minus 1. That was the first question we did. Now, let us simplify it. 2z upon z minus 1 ka square plus z by root 2, because sine pi by 4 is 1 by root 2. Z square minus 2z by root 2 plus 1 plus z upon z minus 1. So this is the answer. If you want to simplify the central term little bit, you can definitely simplify it like this. Z upon root 2, and this root 2 and root 2 will get cancelled. So root 2z square minus 2z plus root 2 plus z upon z minus 1. So this will be the answer for the question. Let's move to the next question. Now z transform of this. So first you open it by sine a plus b. So z transform of sine a sin cos b minus cos a sin b. This is plus. Okay, in sine plus sign is there. Now in this two terms, cos 5 is constant, take it out. Z transform of sine of 3n plus sine 5 is constant, take it out. Z transform of cos 3n. Okay, now again I will apply the formula of sine n theta and cos n theta. Right? So let us apply the formulas. Now we have the formulas with us. So let us apply. You have to remember it for example. Now what is Z transform of sine n theta? Z transform of sine n theta is Z sine theta upon Z square minus 2Z cos theta plus 1. Implies Z transform of sine 3n is what? So n is to n, theta is 3. So here you substitute Z sine 3 upon z square minus 2z cos 3 plus 1. Okay. Same way, z transform of cos n theta is equal to z minus cos theta upon z square minus 2z cos theta plus 1. So z transform of cos 3 theta will be what? Z minus cos 3 upon z square minus 2z cos 3. In place of theta I am putting 3. That's it. So I got this result. I got this result. Okay, this is cos n theta and this is cos 3 theta. Okay, 3n actually. Okay, now substitute these two values here. So what you will get? Cos 5, okay, in bracket z sin 3 upon z square minus 2z cos 3 plus 1. Okay, then is plus sin 5 plus sin 5. Z transform of cos 3n is what? So another bracket z square, or let it be z only, z minus cos 3 upon z square minus 2z cos 3 plus 1. Now denominator is same, so let us take it out. In numerator I can take z common. So z upon z square minus 2z cos 3 plus 1. In bracket, what is left now? Sin 3 cos 5 plus sin 5, okay, z sin 5 minus cos 3 sin 5. Just open the bracket. Okay, so now the next step is z upon z square minus 2z cos 3 plus 1 is the same thing. In bracket, this term I will write as such, z sin 5. Now this, if you observe, it is a formula. Sin A cos B minus cos A sin B, which is nothing but sin of A minus B. Right? So this will become sin 2. Oh, I forgot to put the minus sign here. So now I got my answer as z inside the bracket z sin 5 minus sin 2 upon this thing. So this is my answer. Okay. So let's move to the next question. Now look at this question. Again the same category. Right. Again the same category. You just open the bracket. So z transform of cos A cos B minus sin A sin B. Trigonometric formula. Cos A plus B is cos A cos B minus sin A sin B. Now cos pi by 4 is what? 1 by root 2. Sin pi by 4 is what? 1 by root 2. So I can take out 1 by root 2 outside, and inside I am left with z transform of cos n pi by 2 minus z transform of sin n pi by 2. Correct? Now, the moment you got this, again you can directly use the formula of z transform of cos theta and z transform of sin n theta. Right? So now let us apply the formula of z transform of cos theta and z transform of sin n theta. Okay. So now what is the formula? So I know that z transform of cos n theta is equal to z minus cos theta upon z square minus 2z cos theta plus 1. So here in place of theta, I need to put pi by 2. So z transform of cos n pi by 2. So theta means pi by 2. Okay, see. So just substitute z minus cos pi by 2 upon z square minus 2z cos pi by 2 plus 1. Now what is cos pi by 2? Cos pi by 2 is 0. So z square upon z square plus 1. So this can also be used as a standard result of cos n pi by 2. So z transform of cos n pi by 2 is z square upon z square plus 1. This you will be using in inverse also. This you will be using in difference equation also. So remember this result. Now same way z transform of sin n theta is what? Z transform of sin theta is z sin theta upon z square minus 2z cos theta plus 1. So z transform of sin n pi by 2 will be what? Again in place of theta you put pi by 2. So z sin pi by 2 is 1. Then z square cos pi by 2 is 0. So this term becomes 0 plus 1. So this is the standard result for sin n pi by 2. Correct? This will be the standard result for sine n pi by 2. Now, anyways, now go back to your question and substitute the values here. So, what is the answer now? 1 by root 2. Z transform of cos n pi by 2 is equal to z square upon z square plus 1 minus z transform of sine n pi by 2. This one is z upon z square plus 1. Correct? So, now simplify this. So, this is 1 by root 2. Okay. LCM is z square plus 1. Numerator is z square minus z. So, if you want, you can take z common. So, z minus 1 upon root 2 z square plus 1. So, this is the answer. Simple. So, questions are very simple. Same formulas again and again you have to apply. Few results like 1 k to the power n, sin n theta, cos n theta, cos hyperbolic n theta, sin hyperbolic n theta, that you should by heart. Okay. Hyperbolic is not that much important, but normal sin n theta and cos n theta are very important. Now see this. If I want to find out z transform of cos hyperbolic. So remember that cos a plus b is a formula. Cos a, cos b minus sin a, sin b. But when hyperbolic is there, you can't apply that formula. Okay. So you apply the definition of cos hyperbolic. What is cos hyperbolic theta? E to the power theta plus e to the power minus theta upon 2. Same thing I did. This whole thing plays a role of theta. So 1 by 2, this and this. Now separate it. Exponential rule. So you can write like this. Okay. Now you know this. This is constant, this term. So here you apply z transform formula. Okay. So k to the power n. What is the k value? E to the power pi by 2. So I got this value. I got this value. Just substituted and simplified. When you simplified, again cos hyperbolic formulas you get and you just put the value. That's it. Now this property is very, very important. Okay, as I told you, I forgot to do z transform of n. I will teach you that also, but before that, let us derive this property. Derivation of this property will start from right hand side. So I'll start with minus z d by dz of z transform of n to the power k minus 1. Okay. So now, what is the first thing I'll be doing? I'll apply the definition of z transform. So minus z d by dz. What is z transform definition? Summation n is equal to from 0 to infinity. Okay. N is from 0 to infinity. The function means n to the power k minus 1 and z to the power minus n. Okay. Now minus z. Okay. Minus z summation n is equal to 0 to infinity. I will differentiate it. So n k minus 1 is a constant. Differentiation of z to the power minus n is what? Minus n z to the power minus n minus 1. Simple differentiation I have applied. Okay. Now minus z minus n summation z to the power minus n plus 1. Okay. Now what I am going to do here, this term I can break it like this. Minus minus plus. So zn summation z to the power minus n upon or z to the power minus 1. Let me do this one step more for you. N is equal to 0 to infinity, always you should write. So here z into n, okay, summation 1 upon z to the power n, 1 upon z. Now this z and this z get cancelled because the summation is for n. Okay. Oh, okay students, see here I have done such a big mistake. Now here if you observe, I differentiated the result. Correct? Now minus sign will come out. N will never come out because the summation is for n. Let me rewrite from this step so that there should be no confusion. I'm really sorry. Just by mistake I wrote like that. Okay. Now look at this. Okay. If you are confused, I'll do this step also again. Okay. So let us start now. Minus z outside. Okay. I will differentiate the result. Summation n is equal to 0 to infinity. N to the power k minus 1. Now d by dz of this thing. So minus n z to the power minus n minus 1. Okay, so minus z, and this minus sign can come out. But n I cannot bring out of the summation. Okay, so this become n to the power n minus 1, and this n will become n to the power k. Right? And z to the power minus n upon z. Z to the power minus 1 I can write upon z. So this z and this z will get cancelled. So I'll have minus minus will also become plus. So I'm left with summation n is equal to 0 to infinity n to the power k z to the power minus n. And what is this? This is a definition of z transform. So this is equal to z transform of n to the power k. So that is what is the result. So we are done with the result. So what is the important result I got? Z transform of n to the power k is equal to minus, look at the result, z d by dz of z transform of n to the power k minus 1. Right? Z transform of n to the power k minus 1. Now, in this result, if I put n is equal to, k is equal to 1. If I put k is equal to 1, what will happen? Z transform of n is equal to minus z d by dz of z transform of z n to the power k is 1. So 1 minus 1, 0. Anything to the power 0 is 1. Right? So z transform of n is equal to minus z. Okay. Now z transform of 1 is what? Z upon z minus 1. And I do have d by dz here. Now next step, z transform of n is what? Minus z is outside, this I will differentiate. Question rule you apply. Differentiation of z is 1 into denominator. Minus differentiation of denominator is 1 into numerator upon denominator square. So this is equal to, if you observe, this and this got cancelled. So z upon z minus 1 whole square. So I got a result, z transform of n is equal to this. Z transform of n you can derive directly by using the definition of Z transform also. Okay. So now I have told you how to use the formula here. Okay. But if in case directly they ask find Z transform of n. So either you start with the formula, that is also correct, you will get full marks, or you can start like this also. Z transform of n is equal to, by definition, summation n is equal to 0 to infinity n and z to the power minus n. That is a formula, right? So now if I do it like this, summation n is equal to 0 to infinity, like I have developed k to the power n, z transform of 1, same way I will derive this. So n upon z to the power n. Now when you open the summation, z transform of n is equal to, first term is 0. Okay, then put n is equal to 1. When I put n is equal to 1, 1 by z. When I put n is equal to 2 plus 2 by z square plus 3 by z cube plus 4 by z to the power 4 plus dash dash dash. And if you observe in the first page, I gave you a result. Okay. Okay, so now here what I can do, I will take 1 by z common. So I am left with 1 plus 2 by z plus 3 by z square plus 4 by z cube dash dash dash. Now if you observe, in the beginning I gave you one formula, 1 minus x to the power minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube dash dash dash. So this series I can apply where x is equal to 1 by z. Okay, so I have 1 by z, and here in bracket 1 minus 1 by z to the power minus 2. Now take the LCM here. So 1 by z, z minus 1 to the power minus 2 upon z to the power minus 2. So this become z square by z, z minus 1 whole square. This and this got cancelled, and I got the same result as I have obtained here. So this is a direct way if you don't want to use the formula, and otherwise this is the best way. You remember the formula and use it. Why you need to remember this formula? Because n is easy to do, but when n square you do, it become very lengthy. So it is best to apply the formula in that case. So now let us apply the formula for n square. I know that z transform of n to the power k is equal to, now write down the formula properly, minus z d by dz of z transform of n to the power k minus 1. Now as per the requirement, I will put k is equal to 2. So z transform of n square is equal to minus z d by dz of z transform of n, k is equal to 2 I am putting, so n, right? So this is equal to minus z d by dz of, what is z transform of n? Just now we derived z upon z minus 1 ka square. So next step, minus z, differentiate. Apply quotient rule. Differentiation of numerator is 1 into denominator. Minus differentiation of denominator is 2z minus 1 into numerator upon denominator square. Correct? Now from numerator, take z minus 1 common from both the terms, this term and this term, and that will get cancelled by the denominator. So minus z, what is left? Z minus 1 minus 2z. Z minus 1 I have taken common. So when I take common denominator, it becomes z minus 1 cube, because 1 z minus 1 get cancelled. Okay, you can write it like this, z minus 1 common, and this gone. Okay, next step what I will do? Z minus 2z is what? Z minus 2z is minus z. So minus 1 minus z, minus sign you take out. So z 1 plus z upon z minus 1 cube. So this become the result for z transform of n square. This can also be written as z square plus z upon z minus 1 cube, right? So now let's go to z n cube. So again same formula, z transform of n to the power k is equal to minus z d by dz of z transform of n to the power k minus 1. Now put k is equal to 3. So I'll have z transform of n cube is equal to minus z d by dz of z transform of z square. Right? And what is z transform? I'll write from here because I need space. Minus z d by dz of z transform of z square is this. Write it, z square plus z upon z minus 1 ka cube. Now differentiate. So again division rule. 2z, differentiation of numerator is 2z plus 1 into denominator, minus differentiation of denominator into numerator upon denominator square. Right? So now in the numerator z minus 1 whole square you take common and cancel it by denominator. So I am left with minus z minus 1 square I have taken common. So what is left in the numerator? 2z plus 1. 1z minus 1 is left here. Minus 3z square plus z upon z minus 1 power 6. Next step, minus z upon z minus 1 to the power 4, because 1 2 will get cancelled. Numerator 2z square minus 2z plus z minus 1 minus 3z square minus 3z. Okay, let us simplify this. Minus z upon z minus 1 power 4. Numerator, this will become minus z square. Then this is minus z, minus 3z, minus 4z, minus 1. So minus sign I can take out. It becomes z square plus 4z plus 1 upon z minus 1 to the power 4. So this becomes the formula for z transform of n cube. You can write it as z cube plus 4z square plus z upon z minus 1 to the power 4. Correct? So this is very important. N square, n cube. Now based on this one question is very important. Very often they ask in exam. Now z transform of n plus 1 whole square is what? Z transform of a plus b whole square formula you apply. So z n square, 2n and 1. Now you know the formula of n square, put it. You know the formula of n, put it. You know the formula of 1, put it. Simplify, you get the answer. If it is a 5 marker only, you can finish it like this. But suppose if they ask it for 10 marks or 8 marks like that, more marks, then you have to derive n square and n. In that case, you write down the general formula and directly put k is equal to 1 and 2. So you get the value of formulas for n and n square. Don't derive that formula and directly put the value. Okay, so now with this we are done with the basic questions of Z transform. In the next video I'll tell you damping rule, shifting property, linear property is same as it works in differentiation, which actually we used in few questions also. So damping rule I'll tell you, in which you will be able to do the function which is multiplied by k to the power n. Okay, and then shifting rule. I hope you understood the Z transform concept. If you are getting trouble in any problem, let me know so that I will upload a short video on that particular question. So any problem you are facing a problem, just put in YouTube chat कि this problem kindly explain. I'll give you the simplest explanation. Like the video, share the video and subscribe the channel. Thank you.